Welcome to the channel Motion of Mathematics. In today's video, I will be discussing two questions regarding characteristic polynomial and characteristic equation. So, first question is related to the concept of characteristic polynomial, and the second one is related to the characteristic equation. So, as you can understand here, in the first question, we have to find characteristic polynomial of a matrix A, and this is a 2 by 2 matrix, and in which entries are 2, 5, 1, and minus 3. So, we have to find the characteristic polynomial of this particular matrix. So, I'm going to handle first question here. I will begin with this one. So, if I will talk about the first question, the matrix is like A, S, 2, 5, 1, and minus 3. I want to get here the characteristic polynomial. So, what is the meaning of characteristic polynomial? What is the characteristic polynomial here? The characteristic polynomial is equal to determinant of A minus lambda I. So I will separately find this particular expression. So what is the A minus lambda I? What is A minus lambda I? Firstly, I will get it. So A is 2, 5, 1, minus 3. Minus lambda is as it is, and I is the identity matrix of order 2 by 2. So 1, 0, 0, and 1. So ultimately it is what? It is 2, 5, 1, minus 3, or minus, I can write it like lambda 0, 0, and lambda. So if I will just simplify it, it will be 2 minus lambda, 5, 1, and minus 3 minus lambda. So this is matrix A minus lambda I. If I will take the determinant of this particular matrix, that will be determinant of A minus lambda I. Determinant of A minus lambda I means what? It is 2 minus lambda, 5, 2 minus lambda, and thereafter it is like, let me correct it. It is like this one, 2 minus lambda, 5, 1, and it is minus 3 minus lambda. So we will just try to solve it. If I will try to solve it, so we will get it here like minus 2 minus lambda, right? And it is 3 plus lambda and minus 5. So if we will simplify it, what we are going to get it here, it will be like, I will say, 6 minus 3 lambda and plus 2 lambda and minus lambda square and minus 5 as it is, or it is minus is common, so it is minus lambda square and minus lambda and plus 6 and minus 5. Ultimately I can write it like, if I'm saying, it will be right, it will be like this: lambda square plus lambda and minus 6 minus 5. So it will be lambda square plus lambda minus 11. So this is known as the characteristic polynomial. This is what? This is characteristic polynomial. This is characteristic polynomial for what? For this particular 2 by 2 matrix. So this is the proper way to get the characteristic polynomial of any square matrix. And here the square matrix is of order 2 by 2. So thereafter, I will try to solve here the second question. In second question, we have to find the characteristic equation. And but here the thing is like the matrix is of order 3 by 3. So I will write here separately this matrix A. So I'm going to start the second question here. So in the second question, what is the matrix A? So I will rewrite it here. So capital A matrix is 1, 3, 7, 4, 2, 3. So it is like 1, 3, 7, 4, 2, 3. And the third row is like, if I'm saying 1, 2, 1, right? It is 1, 2, and 1. Now I want to get here characteristic equation. I want to get here what? I want to get here characteristic equation. I want to get here characteristic equation. And characteristic equation is what? It is determinant of A minus lambda I equal to 0. So process is almost same. So what I will do here, I will write here firstly A minus lambda I. So A is what? A is 1, 3, 7, 4, 2, 3, 1, 2, 1 minus lambda as it is, and it is 1, 0, 0, 0, 1, 0, and it is 0, 0, 1. It is identity matrix of order 3 by 3. So how I can continue this? It is 1, 3, 7, and 4 2 3 and it's 1 2 1 and minus I can write it lambda into identity matrix 1 0 0 0 1 0 and 0 0 1. So we will now try to simplify it little bit more. So it will be 1 3 7 4 2 3 1 2 1 and minus it is what? It is lambda 0 0 0 lambda 0 0 0 and lambda. So little bit more simplification is required here. So that is 1 minus lambda 3 7 4 2 minus lambda 3 1 2 and 1 minus lambda. Ultimately it is a minus lambda I. A minus lambda I. Now the thing is like after getting this a minus lambda I need to get its determinant. I need to get its determinant, that is determinant of a minus lambda I. So it will give us characteristic polynomial, right? So it will be what? Determinant of this particular matrix, that is 1 minus lambda 3 7 4 2 minus lambda 3 and 1 2 and 1 minus lambda. So if I will equate this particular term equal to 0, so characteristic equation will be formed. So we already know this. We know that characteristic equation is determinant of a minus lambda I equal to 0. So it will be what? It will be determinant of 1 minus lambda 3 7, right? 4 2 minus lambda 3 and 1 2 1 minus lambda is equal to 0. So after that, what is the process? The process is like we have to solve it. We have to solve this particular determinant. So I'm going to solve it. How I can solve it? I can just expand it like 1 minus lambda, 1 minus lambda, 2 minus lambda, 3, 2, 1 minus lambda, minus 3, and it is like 4, 3, 1 into, not 1 into, it is 1 and 1 minus lambda, and plus 7, it is 4, 2 minus lambda, 1, 2, and it equals to 0. Now thereafter, little bit more simplification. So it will be like 1 minus lambda, and it is, I will say 2 minus lambda, 1 minus lambda minus 6, right? It is minus 3, and it will be like 4 into 1 minus lambda minus 3 and plus 7 as it is, and it will be 8 minus 2 minus lambda, and that is equal to 0. That is equal to 0. Now what I will do here, little bit more simplification I will do. 1 minus lambda as it is 2 minus lambda, 1 minus lambda minus 6 and minus 3. Here it is 4 minus 4 lambda minus 3 and plus 7 as it is, and it is 8 minus 2 plus lambda equal to 0. Now thereafter in the next step we will get it like this: 1 minus lambda, 1 minus lambda, it is 2 minus lambda, 1 minus lambda minus 6 minus 3 as it is minus 4 lambda and plus 1. Or I can write it like this. I can write it like this. I can write it like 1 minus 4 lambda, right? And plus 7 as it is, and it is 6 plus lambda equal to 0. Now we will simplify this particular term. So it will give us 1 minus lambda. It will be what? It will be 2 minus lambda minus 2 lambda and plus lambda square minus 6 and minus 3 and plus it is 12 lambda and plus it is 42 and plus 7 lambda equal to 0. Now again simplifying this one, we will get 1 minus lambda, and it will give us lambda square minus 3 lambda minus 4 and 12 and 7 lambda. It will give us, I mean to say, plus 19 lambda, and plus it will give us like minus 3 plus 42 will give us 39 equal to 0. Now we will simplify this again this term. So it will give us this term. It will give us 1 into what? Lambda square minus 3 lambda minus 4 and minus lambda as it is, lambda square minus 3 lambda minus 4 and plus 19 lambda as it is plus 39 equal to 0. Thereafter if I'm saying, again we will little bit simplify this. So we are going to get it like, if I'm saying, so it will be lambda square minus 3 lambda minus 4 and minus lambda cube and plus 3 lambda square and plus 4 lambda plus 19 lambda and plus 39 equal to 0. So it will give us minus lambda cube. So it is like if I'm saying 3 lambda square and lambda square, it will give us like 4 lambda square, right? And here it is minus 3 lambda and it is 4 lambda, so it will give us lambda and lambda plus 19 lambda, it will give us plus 20 lambda, and thereafter I think like this is left minus 4 and plus 39, it will give us what? It will give us plus 35 equal to 0. So I can little bit more simplify this. I can write it lambda cube minus 4 lambda square and minus 20 lambda and minus 35 is equal to 0. So now this is the proper form, and this particular equation is known as the characteristic equation. Is known as what? Is known as the characteristic equation. Characteristic equation of what? Characteristic equation of this particular 3 by 3 matrix. This particular matrix. So students, in this particular video, I have discussed two concepts with all of you. So first concept is related to characteristic polynomial, where the matrix is of 2 by 2 order, and the second concept is related to characteristic equation, in which I have considered 3 by 3 matrix. So I hope this will be quite useful for all of you. Thank you so much for watching this video.